Hey, it's Lester Martin with Hortonworks University. We're going to continue on with another module in our Hadoop Essentials course. This one's Parallel Processing Fundamentals, and it's really a conversation around the MapReduce framework itself. So some straightforward objectives. It's a pretty short as far as the number of slides that I want to present, but it is somewhat of a dense topic if you really haven't ever really thought about the MapReduce framework. It is pretty simple and novel once you understand it. Can be difficult the first time or two that you hear it, so that's okay. So again, we're just trying to make sure we have good awareness of MapReduce, and as much as we can, we'd like to learn a little more details about how it leverages key value pairs very extensively, and just try to show you that through some simple examples here in the slide, and then ultimately a demonstration using the trucking data like all of our other modules. So what is MapReduce? You know, it's real key here is it's a framework that can take a large problem or a large data set and break them into smaller problems, smaller sub solutions here. And really what we're talking about is reading data out of HDFS and processing that. So what does HDFS do with data? It breaks it into blocks and puts them in different places. So we have a basis of parallelization in the MapReduce framework highly coupled with how HDFS actually stores data. So HDFS stores by blocks, so every block will need a mapper, a piece of code that can read just that bit of information, and it'll be another one and another one, and that can run all at the same time if we have a large enough cluster. Or the number of our mappers is the number of processes, the number of partitions we need. If we can run that many processes at once, then we can run them in one big pass. Now the reality is, at some point there is a need to do something. We may have to do some kind of aggregates or some kind of sums on particular things. Maybe we're doing an average of income by zip codes or something if we're a bank. And so there is this need to do an aggregation. In MapReduce, we have to do that in the phase called the reduce process. And we'll show you some examples why that's there's some arduous activities that have to happen for you to get to the point where you can do that aggregation. What's really nice about the MapReduce framework is that we'll build mappers, we'll build reducers, and we'll let a framework, a rich framework that's been around for a good long time now, take care of that middle activity, the shuffle and sort, that I'll try to explain with a little bit more detail in just a moment here. So let's just make it super simple. Let's think of an extremely simple algorithm. Got a big stack of quarters, and I just want to know, how many quarters I have that are even numbered years. That's not too hard. I'll just start walking through that stack of quarters and counting them off, and everything's happy. But I don't know. What if I've got to count a whole bunch of stacks of quarters? Oh my gosh, I'll have to start working it up. So we say sometimes in Hadoop, and it's just a phrase out there always, how do you eat an elephant? Well, you eat it one bite at a time. So what we really do is we get our friends. We get out there and we take those quarters and we let everybody grab a few of them, and then everyone individually can work in parallel and count up those even number quarters for us. And then ultimately we'll send those answers down to an aggregator, a reducer phase, someone who can say, great, now that I have all the individual totals, I can finalize the last, kind of that last mile total. So that's a super simple example, of course, and didn't show you code or a framework, but hopefully it made a little bit of sense of what we're talking about here. So the next two slides are kind of dense, and I'll try to show a picture right afterwards. But it makes sense to say these things and then show them maybe in practice. So if we think about mappers and reducers, so we'll focus on the mapper, the one that's coupled highly with the block size of the data we're trying to read. And what happens? Well, a mapper, everything in MapReduce works on this notion of key value pairs. So a mapper is handed a key value pair, and a mapper can emit 0 to many key value pairs. It might make sense again to see this in practice, but I want you to hear that kind of that cardinality. A mapper gets a key value pair, and it will produce out 0 to many key value pairs. So a pattern that we see a lot of is maybe reading a kind of somewhat of a text file, and that key in the key value pair for a text file, depending on the reader you choose, is often the key might be the offset of where we are in a particular file. May or may not be that useful to you, and the value might be a row of data. And then what you do with that row and what you omit really depends on the business problem you're trying to solve. And we'll show you a simple one, and we'll do a demo as well with one that aligns with the trucking data. The reducer, ultimately, he's the guy that's going to kind of be the aggregator once things are finished, once the entire map phase is finished up. And just to kind of build you that contract, to help show in a second here, the reducers are actually given a list of, a reducer is invoked with a key value pair. What's interesting about this key value pair, it is that key is uniquely only that key value pair, the key from that key value pair will only be sent to a reducer once. And the value is actually a list of, an enumeration, or a big array of all of the values for that one key that all the mappers previously themselves produced. So we'll show that in a second. It'll make a little bit of sense. And then a reducer, like a mapper, can produce as many as it wants, or none, key value pairs. So what's the old proverbial hello world example? Well, in Hadoop, it's called word count. And what we're talking about in word count is taking a corpus of information, a large body of text, works of Shakespeare, the Constitution, something, and just simply count up how many times the word the and frog and dog and whatever words are in there, how many times, how many total times that word is represented. So this is really just some simple pseudocode of how you would implement that in a language like Java. So we have to code two methods. One's called the mapper, one's called the map, one's called the reduced. You can tell what class they go to, the mapper and the reducer. And as you look at that signature, just like I said, a map takes a key value pair. Well, again, I mentioned that our scenario here is we have a text file. So really what we care about is that value, the key value side, that we'll call that the input value. The input key for us is just an offset of the file, so we're not going to worry about it. And then all we're going to do is tokenize that big string and pluck out all the individual words. And then for each one of those words we find, let's just raise up a key value pair that is of the word and then number 1. So I'll show you the example in a second, but the frog, dog, the one, frog one, dog one, if it was just the frog, dog. And then ultimately reducer, and again, I'll show you this in action just a moment. A reducer is going to take, going to receive a key value pair, again, a somewhat more sophisticated key value pair. A single call will occur for a given key, and then the value for that key value pair is the value, all of the values that all the mappers produced for that given key. So in our case, in the word count, we're talking about a word, a unique word like frog. And since we raised just ones earlier, we're going to see 1, 1, 1, 1. And we just have a simple algorithm here that's just going to walk through that, total those up, and then raise out, emit out that word again with the final count. So let's see that word count in action. And I happen to like good old Dr. Seuss and the good books a lot of us grew up on, and Green Eggs and Ham is a classic. So here's an example. Maybe I'm showing an example of 2 rows. I will not eat green eggs and ham, and I will not eat them, Sam I am getting called twice. And in this case, what we're really going to do is we're going to emit out on the top one. We're just going to walk each one of those words like I mentioned. And so if you just look from left to right, I will not eat them, green eggs and ham. It produce I will not eat them. I will not eat green eggs and ham. Each one of those with just a key value pair with the value of 1. The second row kicked in the same thing. I will not eat them, Sam I am. So this two independent calls to this mapper produced a bunch of key value pairs. And if you start imagining, there are going to be definite words like I and eggs and ham for sure are going to be many of those that are involved in this magical book. So what's going to ultimately happen, that shuffle and sort phase, that's the magic that ensures that a single reducer gets called with it only gets called once for a given key that was emitted out of the map phase. So in our case, what we're really saying here is, especially if we took those exact words here, so the word is I is in there 3 times. I. Will is in there twice, and eat is in there twice. So let's verify that's the case. I 3 times, will 2 times, eat I think we said 2 times, and I think there's a few other words not. And then what this reducer is going to do is each one of these rows, each one of these key value pairs will get processed, and if you remember the logic, all it did is just kind of counted up the attributes that were inside of there. So we end up producing, the output of this ends up being the final count for how many times the word I, Sam, and each one of these independent words was implemented. Now this is a real small 2 rows. I wanted to make the numbers sync up, especially if you look at them a little later after the session's over, to make sure they really make a lot of sense. So that was a lot. It was trying to introduce MapReduce as a framework in 5 to 10, maybe 15 minutes. It's worth kind of walking through. I think those 4 or 5 slides definitely tell a story. You just might have to read it once or twice. But I'll try to put all of that back on one slide here, kind of a quick recap. So we have our green eggs and ham file in HDFS, and we end up producing a bit of mapper code that's going to be handed a row at a time. So this row started out, I will not eat green eggs and ham. And what is that mapper going to do? It's going to output a number of key value pairs. And in fact, it's going to output a key value. The number will be the number of words that were in that line. So there we go. I will not eat green eggs and ham. Then the framework itself, nothing that you'll write. The framework itself has a shuffle and sort phase that's going to ultimately put these together such that it can invoke a reducer with a given key, a unique key, and then all the values that were for that unique key. So as we see here, there's going to be many words that have a bunch of ones by them in this example. And then we'll implement a piece of code on the reducer that all he's going to do is just walk through and total up those numbers and produce things like, hey, there were 223 I's and 82 knots in that body of knowledge, that body of text. And we'll write this information back off into HDFS. Again, that's a whirlwind tour of MapReduce. We'll do a demo in a bit that you can look at later. Files will be out on GitHub. You can try to rerun those yourself later, but we'll definitely see those in action. So quick knowledge check, not a trick question, but what are the 2 primary phases of MapReduce? Yes, they are map and reduce. Those are the 2 primary phases. And definitely what dictates the number of mappers? Well, it's going to be the blocks, the total number of blocks that your input data accounts for in HDFS. Same thing for the reducer. Well, in the reducer, we have an opportunity, and I might not have said it, but in the reducer, we actually can control via a definition. We went 2 reducers, went 1 reducer, went 200 reducers. So we get to control that, which is itself can be somewhat of a tuning concept, a tuning exercise itself, but definitely that control is in our hands. How about the inputs and outputs, key value pairs in and out of mappers and reducers? Well, all mappers and reducers always receive a single key value pair. Probably the difference is going to be on the reducer that the value that a given key would only ever be called once, only pass to reducer once, and the value of that key value pair is a list of all of the values that maybe that the combined set of mappers have produced. And they both can return 0 to many mappers. 0 to many key value pairs as appropriate. True false, can you have a reducer only job? Well, I didn't talk about this. And if you remember when we discussed Scoop earlier, we kind of said Scoop's a map only job. So there is a concept called a map only job, but definitely not a reducer only job. And if we do happen to get a map only job, we have a great opportunity to run very, very quickly, because we could completely eliminate the shuffle and sort phase, much less the ultimate reducer phase itself. So yes, map only, not a reducer only in classic MapReduce. And I'll finish up with a quick question about, so why do you think frameworks like Pig and Hive were built on top of MapReduce? Well, MapReduce is a fine-grained framework. And for many problems out there, these other tools, especially Hive, can be seen as SQL, and Pig maybe a little bit more of a high order. Read this, filter this, aggregate this. Those frameworks, for most of us, for most people, for most problems, will satisfy, and we can actually get our work done and get into running a whole lot sooner. But there are going to be special needs and requirements, and sometimes it can be just performance. It can be a variety of things that MapReduce still may fill the bill. So, quick summary. I think I just touched on all these things. We break a big problem into a bunch of little problems. We definitely walk through the number of type of key value pairs for mappers and reducers. So you have that information again here. And as I said, as I was just saying, that to be honest, it's a fine-grained framework. It's a programmer's framework, and you have to think in this notion of keys and values and map and reduce. And when you have a complicated problem, you in fact may build multiple MapReduce programs that have to fit together either in sequence or in parallel, and then ultimately in sequence to get a final business problem solved. So again, some of these other frameworks are a little bit more, at least quicker from a development time, suited for solving those. Okay, so it looks like we have just enough time. We'll take a few minutes and run through another live demonstration of a MapReduce job using the trucking data sets.